Okay, hello Cloud Gurus and welcome to this lecture. In this lecture, we're going to look at load balancers and health checks. So this is a lab and you will need to log into the AWS console. Okay, so here I am in the AWS console. I'm going to go over two services and we're going to start with EC2. And what we're going to do is we're going to go ahead and launch an instance. We're going to launch two different instances in two different availability zones. So I'm just going to use a T2 micro and go ahead and configure my instance details. I'm going to do it into my default VPC. I'm going to scroll down and I am going to give this a bootstrap script. So here's my bootstrap script here. It is available in the resources section of the course. And essentially all it's doing is it's running a yum update. It's installing Apache, it's starting the Apache service, and then it's making sure Apache starts back up if this EC2 instance reboots. Then it's going over to our var www HTML directory and it's writing a little web page. And the web page just says, this is web server 1. And actually I'll just fix it so that it ends our header and it ends our HTML. And there we go. And then it's going to output that to index.html. Okay, so I'm going to paste that in there. And then I'm going to go ahead and add my storage. And then I'm going to go ahead and add my tags. In terms of tags, I'm going to make this web01. And sorry, let's just go back and make sure that we put it in a specific availability zone. So I am going to put this into a specific subnet. I'm going to do this into EU West 1A. So do 1A for whichever region that you're using. And then I'm going to go and I'm going to change this to name, and then it's going to be web01. And then we're going to add our security groups, configure our security groups. If you just use your web DMZ security group, that's fine. Review and launch, and then I'm going to go ahead and launch it and just acknowledge that you've got your key pair. Then we're going to do exactly the same thing, except we're going to change the bootstrap script to having web server 2. So let's go Amazon Linux 2 AMI, T2 micro, scroll down, and in here we'll paste our bootstrap script and just change this web server to web server 2. And then also make sure that this goes into a separate availability zone. So we're going to go back up and we're going to go over to our subnet and we're going to put this into West 1B. Next, I'm going to add my storage and I'm going to add my tags. And again, I'm going to change my name and that will be web02. And there we go. I'm going to add my security group, use an existing security group, and we're going to use our web DMZ security group and go ahead and review and launch and hit that. So those two instances are now launching. You should just be able to navigate to the public IP address to check that the web server has worked or the bootstrap script has worked. So I'm just going to paste that in here and we can see that web server 1 works. And if I grab this one here, I'm just going to grab the IP address and just open up a new tab and type in the IP address. And there we go, we've got web server 2. So we've got web server 1 and web server 2. So they are definitely in different availability zones, as you can see there. So what we're going to do now is we're going to go over and create our first load balancer. So load balancer is here under load balancing. We're going to go in and create a load balancer. So again, there's three different types of load balancers: application load balancer, network load balancer, and classic load balancer. In this lab, we're just going to use classic and application. I don't particularly want to use network because they are expensive. So let's go ahead and create a classic load balancer first. I'm going to call it my classic ELB. And then in here, we're going to do it inside our default VPC. You can have internal load balancers. This means that they're inside private subnets. We're not going to do that. You can also enable advanced VPC configurations. And this basically allows you to select which subnets that your Elastic Load Balancer is going to be deployed into. And you should always have a minimum of 2. Again, I'm not really going to worry about that. In here, we configure our listener configuration. So we could do it on port 80. You could do it on HTTPS. So on port 443. I'm just going to leave it as port 80. I'm going to go and use our existing security group. So I'm going to use my web DMZ. And then I'm going to go ahead and just hit next. And then this is where we configure our health checks. So we want it to be checking index.html because that is our web page. It's going to be doing this using HTTP on port 80. Now our response timeout, if you ever want to know what these are, just sort of hover the mouse over the info, but this is the time to wait when a response from the health check. So we want this to be passing or failing health checks really, really quickly. So I'm going to make this as 2. And then the interval is the amount of times between health checks. So I'm going to make this 5 seconds. So every 5 seconds it's going to wait and see if it's passed a health check. So down here, the unhealthy threshold is the number of consecutive health check failures before declaring an EC2 instance as unhealthy. So I want that as a minimum of 2. Here's our healthy threshold. Let's go ahead and make this 3. So essentially in 10 seconds, it will detect whether or not our EC2 instance has gone down, and it will take 15 seconds for it to go ahead and become healthy. Next, let's go ahead and add our 2 EC2 instances. So I'm going to add Web01 and Web02. In here, you've got enable cross-zone load balancing. This basically distributes traffic evenly across all targets in the availability zones that is enabled for the load balancer. So we definitely do want that. In here, this is connection draining. So this is the number of seconds to allow existing traffic to continue flowing. So that's down for 5 minutes. Next, we're going to go in and add our tags. I don't particularly want a tag for this. And now I'm going to go ahead and create my load balancer. Now, just remember, load balancers do take you out of free tier. 9 times out of 10, this is where you're going to get a cost, is when you create a load balancer and then you forget about it. So do just bear that in mind. And in here, we've got our classic load balancer. It has now been created, and we're given a DNS address record, or a DNS name. Now, note that we're never given an IP address for an Elastic load balancer. So what I want you to do is copy that DNS record into your clipboard. Before you navigate to that, what you might want to do is just go and make sure that your instances are in service. So we've got in here, right now my instances are out of service, so it needs to go ahead and pass that health check. So I'm just going to wait for a couple of minutes while our instances come into service. Okay, so those instances are now in service. You can see it in here. So all we need to do is now browse to the DNS address of our Elastic load balancer. So go ahead and put that in your browser. Okay, so I'm just going to paste it into my browser, and I'm going to go ahead and hit enter, and there we go, we've got web server 2. If I do a hard refresh, you'll see that sometimes I hit web server 1, sometimes I hit web server 2. So what we're going to do now, we're going to go back over to the AWS console. I'm going to go over to EC2, and I'm going to go ahead and shut down web server 1. So I'm going to go to my actions, instance state, and I'm just going to stop it. I'm not going to terminate it. So that is now stopping the instance. And of course, as soon as this instance is stopped, it's going to stop serving HTTP traffic to my load balancer. So my load balancer is going to detect that using the health check. And essentially what it's going to do is it's going to mark the instance as unhealthy and take it out of the load balancing pool. So I'm just going to pause the video while this stops. Okay, so that has now stopped. Now, if we go back over to our Elastic load balancers and we click on here, we can click on our instances, and you can see that one is in service and the other one is out of service. And if I go back to my browser tab and I hit refresh, I'm now only going to get web server 2. I'm not going to get web server 1. So our load balancer has detected that web server 1 has gone down, and now it's sending all our traffic to web server 2. So that's all that classic load balancers do. You can also do some monitoring in here with CloudWatch. You can have some CloudWatch metrics for your load balancer. But you can see that it's not very intelligent. It's basically a dumb load balancer is the best way to put it. So let's go ahead and create a new load balancer. Before I do that, let's just go over to EC2, and I'm just going to power up my web server 1. So I'm going to go over to my actions, and I'm going to go ahead and hit start again. And then what we're going to do is we'll go in and delete our Elastic load balancer, our classic load balancer, I should say, because we're not going to use it anymore. And so I've deleted that. And then what I want to do is I want to go in and go to target groups. I'm going to go ahead and create a target group. And a target group is basically where your load balancer is going to route requests to the targets in that target group, and using the target group that you specify and perform health checks. So it's basically, you could have a group of EC2 instances for your European customers. Then you could have different ones for your American customers, which have different language settings, etc. And you can actually create application load balancers that detect it and send it to the right groups. So I'm just going to call this web group 1 is the name of my target group. Target type, we're going to do it by instance. You can also do it by IP or by Lambda, but because we're using EC2 instances right now, we're going to go ahead and just use instances. IP address, you could basically have web servers that are not inside AWS, and you just have the public IP addresses. And then Lambda we're going to cover off in the serverless section of the course. We're just going to do it on port 80, so on HTTP. And then down here, it's asking us for our health check settings. So the path we're going to look for is index.html. And we can go in here and do our advanced health check settings. So again, I'm just going to change the threshold. So I'm going to have the healthy threshold as 2, unhealthy threshold as 3. Timeout is the amount of time in seconds during which no response means a failed health check. So let's just do it at 5. And our interval, I'm going to do this at 5 as well. And then the success code down here, this is a HTTP code, so 200 it means it's been successful. Let's go ahead and hit create. It's saying the health check timeout must be smaller than the interval. So let's increase this to 6 and go ahead and hit create. And that has now created our target group. So we've got our target group, but the next thing we need to do is go in and add our targets. So we need to go in and add our instances. So I'm going to go in and hit targets, and then in here I'm going to go edit. And then what we can do is we can go in and add web 01 and web 02 and go ahead and hit save. And that now adds it into our target group. So the next thing we need to do is go in and create our load balancer. So let's create a load balancer. This time we're going to use our application load balancer. I'm going to call this myALB. So myALB. In here, it's going to make it internet facing. We're going to do it over HTTP. In here, you specify the availability zones. I want it in every availability zone. I'm going to go ahead and hit next. And it's just giving us a warning that it's not using HTTPS, but that's fine. We don't need to do that at this stage. I'm going to put it into our web DMZ security group. So it's going to go into there. And now we're going to configure our routing. So we can use the new target group, or we can use our existing target group. So we're going to use the existing one that we just set up. So web group 1, it's done by instance. It's using protocol HTTP on port 80, and it's looking for our index.html. So go ahead and hit next registered targets. It doesn't have any registered targets just yet. We'll go in and do that in a second. Let's go ahead and review and go ahead and hit create. So that has now created our application load balancer. What we need to do is just go over to our target groups and go into our targets. Right now we have no registered targets, but what we need to do is go ahead and add them. So just hit edit, click in here and say add to registered, and then go ahead and hit save. And then that will add it to our registered group. And then basically what we need to do is just pause the video and wait for this status to change from initial into registered. So let's go ahead and refresh the page, and you can see that the status has changed from initial to healthy. So our targets are now behind our application load balancer. Now you might be wondering, how is this more intelligent than the other load balancer? Well, if you go into load balancers and you go down to here, you can see in here you've got your listener. So you've got your HTTP listener ID, and you can go in and view and edit rules. And so you can go in and create rules. And it basically builds out this if-then sort of tree. So it's beyond the scope of this course to show you this in a lot of detail, but you should, if you just have a play around with it, I mean, look, you can go in and say add condition, so you can do it on a host header, or you can do it on a path, then add an action, forward to, redirect, return fixed response, etc., etc. So you can build this out. Now, if you do want to learn this in a lot of detail, we do have a dedicated course to application load balancers on the A Cloud Guru platform. But for your exam, basically what you need to know is that application load balancers are much more intelligent than classic load balancers. You use application load balancers if you want to do intelligent routing, like something like this. You'd use network load balancers if you need a fixed IP address for your load balancer, or if you need ultra high performance. And then you'd use classic load balancer if you just need really simple routing and you don't need any intelligence behind it and you want to keep your costs down. Now let's go and check that this is actually working. So if we just go over to our application load balancer, we go over to our description. You might want to make this a bit bigger so you can see it. Down here we've got our DNS name. Copy that into your clipboard, and I'm just going to paste it in here. So this is my new application load balancer. There we go. We've got web server 2, web server 1, web server 2, web server 1, web server 2. So it is definitely working. So onto my exam tips. We'll just remember the 3 different types of load balancers: application load balancers for intelligent routing, network load balancers for very high performance, and then classic load balancers where you want to keep your costs down. You don't need any intelligence built in. Remember that a 504 error means that the gateway has timed out, and this means that the application is not responding within the idle timeout period. So what should you do? Well, you should troubleshoot the application. Is this going to be the web server or the database server? Also remember that if you need the IPv4 of your end user inside your classic load balancers, you need to look for the x-forwarded 4 header. And then finally, just remember that instances monitored by ELB are either in service or out service, and health checks check the instance's health by talking to them. And load balancers always have their own DNS names. You're never given an IP address. Do read the Elastic Load Balancer FAQ for classic load balancers. In fact, I just read the FAQ for all of load balancers because they do come up. They will come up, probably 10 questions in your exam will be on the different load balancers. So bear that in mind as well. And if you want to do a deep dive on application load balancers, check out our deep dive course on A Cloud Guru. So that's it for this lecture, everyone. In the next lecture, we're going to look at some more advanced concepts with elastic load balancers. We're then going to move on to auto-scaling groups, and we're then going to look at how we can create highly available architectures, or HA architectures. And what we'll do is we'll go through it and create a highly available WordPress site. So if you've got the time, please join me in the next lecture. Thank you.